students. How are you? Today, we are going to start a very new topic, which is naming covalent compounds as well as ionic compounds. So before starting that topic, we will little bit understand about what is covalent compounds and what are ionic compounds. So we know that during covalent bonding, there are atoms involved, but in case of ionic bonding, ions are involved. Positively charged ions are called cations, and negatively charged ions are called anions. You know very well about cations and anions. Now we are going to cover how the electrons are distributed between covalent bonding and ionic bonding. So during covalent compounds, electrons are equally shared between the two elements, which are both the nonmetals we are going to cover later. But in case of ionic bonding, it is transferred from positive, means metals, to non-metals. Okay, that's why metal have positive charge and non-metals have negative charge. And this kind of cases where electron is transferred, it leads to the ionic bonding. Now, what kind of interaction is involved? Both attractive and repulsive forces are involved in the cases of covalent bonding, and it can be polar, non-polar, basis of on the basis of electronegativities between the covalent compounds elements, whatever elements are present. If the metal is more polar, then there will be more polarity. If there is less difference in the polarity or electronegativity, there will be less polarity. And ionic compounds, there is a weak electrostatic force which keeps the bond together. So there is the involvement of electrostatic force between two atoms, so which keeps them together. So let me show you what are the examples of covalent bonding. So H2O, you know, the simple water molecule, it is an example of covalent bonding where oxygen and hydrogen, in between these two, the electron pairs are shared. Similarly, chlorine. This chlorine gas is also an example where electron pairs are shared. But here is an example of NaCl where Na positive is there and Cl negative is there. So it is a combination of anions and cations. Similarly, calcium carbonate. Okay, Ca2 positive, CO3 2 negative. So calcium carbonate, it's an also the example of ionic compounds. Now let's start with the nomenclature. Suppose you faced one compound with a molecular formula. Then how you are going to identify whether it's an ionic compound or non-ionic compound or covalent compound? Then how you start naming? Very, this is a flow chart. Okay, you can see here, this is a flow chart from where you can find out how to do the nomenclature of any compound. First of all, you have to find whether this compound contains a metal or a non-metal. If a metal and non-metal is present, definitely it will be a ionic compound. Okay, if a metal and non-metal is present, it is an ionic compound. Otherwise, if both the things are non-metals, both the elements are present as a non-metal, then it is a covalent compound. So if metal and non-metal is present, it is an ionic compound. Otherwise, it is a covalent compound. In ionic compound, the positive charge metal ions, whatever metal ions are there, cations are there, it should be written on the first. Okay, first it starts its name with the cation and the suffix, that is non-metal anions. So anion is ended with a suffix which is written at the end. What is the suffix we use for the anion? IDE, like sodium chloride. It's an example of ionic compound. We are going to cover more in detail about the nomenclature of ionic compounds. So sodium chloride, you know what is the formula of sodium chloride? Yes, it is Na positive and Cl negative. Now on the other hand side, if you received a compound where both the things, all the two things are non-metals, and if these things are non-metals, then these things are called covalent compound. Next thing, what you are going to check whether these covalent compounds carry hydrogen or not. Then again, you have to check if hydrogen is present, hydrogen is there. Then next step, you have to check whether oxygen is there or not. If oxygen is there, then it will be called oxyacid. Otherwise, if oxygen is absent, it is called binary acid. Let me revise again it for you. If a element, if a compound, if a formula given to you to identify whether it's ionic compound or covalent compound, and it contains both the element as a non-metal, then it's a covalent compound. Otherwise, after getting identifying that it is a covalent compound, you have to find out whether hydrogen is present or not. If hydrogen is present, then you have to check whether oxygen is there or not. If oxygen is there, it will call oxyacid. Otherwise, it will be a binary acid, which start with the hydrogen as a prefix. Means the element will start as a hydrogen or hydro prefix. Elements, the whatever things will end with AC, IC, and at the end you have to use word acid. Similarly, oxyacid will be there if the oxygen is present. Then there you have to use ATE. What are the suffix you are going to use? ATE at the end. Okay. There will be no hydrogen as a prefix. You have to remove that thing. You have to use suffix ATE, IC, ITE, OUS. There are more examples. I'm going to tell you. Suppose you identify that compound is covalent, but you found that it has no hydrogen. Then whatever compound are there, you have to find out which one is cation, means with a positive charge, and anion with negative charge. So whatever number is written with that numerical, you have to put as the numerical prefix. Okay. For example, I have written N2O4. Then what you are going to write this name as dinitrogen. Okay. Tetrafluoro or tetraoxide, sorry. Dinitrogen tetraoxide. Tetra means 4 and di means 2. So these are the Greek prefixes. What di and tri, this is Greek prefixes. We are going to cover more about this in upcoming slides. Okay. So this is a flow chart. This all things are a flow chart to identify whether a compound is ionic or covalent, or how you are going to name a ionic and covalent compound. Let's go and cover more in detail about naming of ionic and covalent compound. So ionic compounds, as already told, includes one metal, which is cation, one non-metal, which is anion. So name of the ionic compound is composed of the positive ion that is derived from the metal. Here it is some examples of given where ionic compounds are given, that is called sodium bromide, magnesium chloride, ammonium sulfate. So here you can see that metal already written. After that, whatever anion is there, that is ending with IDE. Okay. Here it is polyatomic. That's why we are using ammonium and sulfate, not IDE. We are not using. We are using a polyatomic. So if any ionic compound is there, how to write a positive metal? We are directly writing the name of the element as a sodium or magnesium. But in case of halide, we end is IDE as a negative charge. So Br negative, we are writing as ID. Cl negative, we are writing as ID. SO4, 2 negative, we are writing as a sulfate. This we are going to cover more. Now, how you are going to write monoatomic positive ions in terms of elements? Sodium ion, then we write sodium, where plus sign we give as a superscript. Similarly, Ca2 plus, K plus, where we can see the plus sign we are giving at the top. Zinc with 2 positive charge, we write Zn 2 plus as the superscript. Similarly, H plus. Strontium, also strontium ion is there, 2 plus, hydrogen ion is there. Then we now there are some elements, some metals like transition metals. Have you heard about D group elements? So these are transition elements or transition metals. They show multiple oxidation states. How we are going to name that? If they are having multiple oxidation state, how you are going to name that iron with +1 oxidation state, +2 or +3 oxidation state? So in that case, you have to name the number, whatever element is there. So you have to write metal, name of the metal. In bracket, you have to write which oxidation is, whether it is +1 or +2 or +3, whatever oxidation state is there, you have to write the name of the metal. and in bracket you have to write the Roman number of the oxidation state. So there are positive ions that have more than one oxidation state in case of transition elements, so which indicates the charge of the ion in Roman numerals. Here you can say that iron with +2 charge, we have written iron, in bracket we have written 2. Okay. Similarly, in the case of tin, where the +2 ion is there, so here you can say that there are two things where 2 is involved. Copper plus 1 charge, so copper, in bracket we have it 1. So here you are going to do this thing for me. You can see iron is there. Iron we are writing is +3 oxidation state. So student, can you tell me how we are going to write this? Okay, that's nice. Similarly for tin also, you can find this. Yeah, exactly. Copper also you can write the same way. Now we are going to discuss some about polyatomic things. What do you mean by polyatomic things? What do you mean by polyatomic things? Okay, so polyatomic means, poly means many. Okay, so poly means many atoms. Here you can say that this polyatom, we use suffix O, N, I, O, N, I, U, M. Okay, so O, N, I, U, M. So this is the suffix we are using for polyatomic ions. So here we are discussing, there are some examples of H3O positive, which we known as hydronium ion. Okay, what we call hydronium ion. Then NH4 positive, we call it as ammonium ion. Okay, so these are all about positive ions. Now we are going to cover some of the negative ions. As we already discussed that negative ions, we end up with IDE. What we are covering? IDE. So this thing, fluorine is called fluoride. Okay, fluorine with negative charge, what we call chloride. So tell me what we call about bromine. Exactly, that is called bromide. I negative will call iodide. That's nice, fantastic. Then what we are going to say? O2 negative. Exactly, we are going to call it oxide. Okay, and it is used as a suffix. What suffix we are using? What suffix we are emphasizing is IDE. Okay, IDE. Okay, S2 negative sulfide, right? N3 negative nitride. Remember, N3 negative. There is this 3 negative charge. Phosphide, 3 negative charge is there. Carbide, 4 negative charge is there. So you have to keep in mind, carbide means 4 negative charge. Phosphide means 3 negative charge. Nitride means 3. Then oxygen, sulfur, these carries 2 negative charges. And here all the elements are carrying 1 negative charges. So these things you keep in mind. Now what we are going to discuss about polyatomic negative ions. Already we discussed here polyatomic positive ions. Next we have discussed polyatomic negative ions. Very good. So we are going to discuss polyatomic negative ions. So there are polyatomic means there are many elements with one species and they have many different charges. So first we are going to discuss polyatomic negative ions with one negative charge. Okay, then polyatomic negative ions with 2 negative charge and 3 negative charge. So first we are going to discuss bicarbonate. Bicarbonate, you can see that it is written bicarbonate. How you are going to write in the elemental form or in the formula wise, you can see HCO3 negative -1 charge. Then acetate CH3 COO negative. Nitrate NO3 negative. Nitrite NO2 negative. Okay, you can see. Can you tell me about permanganate? Have you heard about potassium permanganate? Yeah, the same thing we are going to discuss here. Good. So it is MnO4 negative. Cyanide Cn negative. Now this thing you are going to tell me, HS4 negative, what is it? Exactly, hydrogen sulfide. Okay, ClO4 negative, perchlorate. Good, good. Now tell me what we are going to write for chlorate. Yeah, chloride. Okay, hypochlorite, ClO negative. Hydroxide will be OH negative. So -2 ions are there. Okay, now the 2 negative charge we have going to discuss about polyatomic negative ions which is having 2 negative charge. So 2 negative charge is carbonate, CO3, 2 negative. Exactly. Sulfate, it is SO4, 2 negative. Sulfide, SO3, 2 negative. So what is the difference between sulfate and sulfide? You should know that sulfate is SO4, 2 negative. Sulfide is SO3, 2 negative. And what is thiosulfate? You have to keep in mind what is thiosulfate. It is S2O3, 2 negative. Okay. Now peroxide. You have heard about hydrogen peroxide. Here you can see oxygen is having 2 negative charge. Chromate is having 2 negative charge, where CrO4 2 negative. Dichromate, read it for me. Exactly, Cr2O7 2 negative charge. Hydrogen phosphate, HPO4 2 negative. Now we are going for the -3 charges. Okay. So what is -3 charge for polyatomic ions? There are some examples like phosphate, which we write as a PO4 3 negative. Borate, that is BO3 3 negative. Arsenate, ASO4 3 negative. So this is the rules for memorizing the negatively charged spaces. Some polyatomic spaces. Now we are going to discuss in more. That if it is polyatomic ions, we know that we have to end in with it. Then suffix, what are the suffix for polyatomic ions are ITE, ATE, and IT is, what is the condition where when we are going to use ITE? When there is a low oxidation state, we are going to use just a minute. Yeah, we are going to use ITE in case of low oxidation state, or you can also say that there is a lower number of oxygen atoms present. Okay, so here is an example where given nitrite where NO3, NO2 negative is there, so it is an oxidation number of +3 and two oxygen atom is present. But in case of ATE, okay, there should be higher oxidation state. Okay, and you can see the nitrogen is here in the case of +5 oxidation state, whereas there are 3 oxygen atoms. In the case of nitrite, it was 2 oxygen state. Similarly, there is prefix also we can use hypo and per. Okay, like hyperbromite ion is there. So hypo indicates lowest oxidation state, per in hypo prefix. So hypo prefix indicates lowest oxidation state. And per indicates highest oxidation state. Okay, so these are the suffix we are using. For example, per iodide, IO4 negative, PRO4 negative. There are other example of ions which are polyatomic, hydroxide, cyanide, peroxide. Okay, and these are the exception for the above mentioned rules. So these are the positive rules for ionic compounds where we in detail discussed how we are going to name a cation and anion combined. Let's discuss more about, let's solve some of the problems. So here are some ionic compounds, how we are going to solve it. You know that sodium bicarbonate, first example we have sodium bicarbonate. Can you help me with that? What is this? What bicarbonate things we called? Here you can check. Bicarbonate we have checked and we found that bicarbonate is HCO3 negative. So how we are going to write? We are going to write NaHCO3. Sodium fluoride, Na plus F negative. How we are going to write? NaF. Iron chloride, iron has multiple oxidation state, and while naming the positive oxidation state, we are 3 means F, it is in +3 oxidation state, Cl, and 3 here we are going to write, because if you check X, so Iron will be in +3 oxidation state. Sodium carbonate, we are going to write Na2CO3. Carbonate is means +2 oxidation state. Okay, sorry, Na is +2, CO3 is having 2 negative charge. Copper sulfate, CuS4. Magnesium hydroxide. Now you going to tell me what is magnesium hydroxide? Mg. Oh, exactly. It will be MgOH twice. What is barium nitrate? Barium means it is having +2 donor. So it will be NO3, sorry, NO3, 2. Lithium sulfate. Sulfate is having 2 charge, so it will be 2SO4 lithium sulfate. Okay. Now these are the examples. Here you have to write. This is one I am solving. Rest of the things you will do. Okay, do it now. Exactly. Rest of the things you are going to do it for me. Now we are going to next how we are going to name the covalent compounds. And we already discussed that covalent compounds are non-metal combination. So there are 2 non-metal present, then it will be covalent compound. So for naming covalent compound, oxidation states plays a crucial role. Okay. So with positive oxidation state, whatever positive oxidation state, it will be named first. And then whatever suffix will be there, IDE for negative oxidation state number. Okay. So Hi is there, hydrogen iodide. NO is there, nitrogen. These are some examples, nitrogen oxide, barium fluoride. So this is first rule is there that you have when 2 non-metals are there. So metal with positive oxidation state will come first. Okay. So there are positive oxidation state. For oxidation state, I am writing OS. Negative oxidation state. So it will become first in the case of covalent compound, and it is the suffix with iodide, IDE. Same thing here, hydrogen is having positive oxidation state, that's why it comes first. Iodide is having negative oxidation state, that's why it is coming last. Same with the nitrogen oxide, bromine fluoride also. Okay, now what are the things for element? If the number of atoms are there, we use Greek prefixes. So we are using Greek prefixes to add the name to the element. Okay, so this is mono, di, tri, tetra. For 4 we are keeping tetra. For 3 we are using tri. For 2 di, 1 mono. 5 for penta. 6 hexa, hepta, octa. You all know these terms. 10 deca. Is prefix mono is normally omitted. We don't use that thing because it's a kind of to avoid any confusion, to avoid any redundancy, we don't use mono. But there are some examples like carbon monoxide where we are generally using this thing. So we don't use mono terms, and we should not use first element in the name as mono. Okay, whatever name starts, we cannot write mono hydrogen iodide, mono nitrogen oxide. It is a thing we avoid. So it is one of the rule. Next thing, if anything is there, like Greek prefix is there, we usually drop that if anything with start just a bit. Okay. So the O or A at the end of a Greek prefix is usually dropped when the element name begins with a vowel. Suppose any element you are using element which name starts with A, E, I, O, U. A, E, I, O, U. Like oxide, pentaoxide. We don't write pentaoxide. We omit this O. It will be pentoxide. Okay. So if any name, Greek prefix you are using like mono, di, tri. So if tetra, penta. So if it is like that, you have to avoid using that term. Okay. Avoid using A. Instead of you use, remove that thing and you have to use oxide like pentoxide. Okay. Here it is A, E, I, O, U. Any element with start with this. Before that, you are going to use Greek prefixes. Then you should not use the O or A, which ends with the prefix. Okay, which is ending with the prefix. Like pentoxide, I gave you example. O5 it is written. You cannot write pentoxide. You have to write pentoxide because this is omitted. This A is omitted. Okay. Now here are some examples. We can see disulfur tetrafluoride. So you have to do, it is quite easy to name. You have to just write S2F4, whatever. Disulfur means 2 sulfur, tetrafluoride means F4. Carbon trioxide. So carbon is single, oxide is 3. Okay, trioxide, 3 oxygens. The nitrogen pentoxide, NO5. It is nitrogen, not dinitrogen. Okay, nitrogen tribromide. So it will be N bromine 3. Yeah, exactly, Br3. Now you have to do this for me. Okay, what is this element? It is dinitrogen heptachloride. So what you are going to write for nitrogen? N. Okay, you are going to write N. And dinitrogen means 2 will come. Heptachloride means chlorine. Hepta means 7. Exactly, fantastic. Then what is for carbon tetrachloride? Write it for yourself. Do it for me. Okay, 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 that's nice. Then hydrogen monochloride, that is good. Trihydrogen monophosphide. What will be the answer for this? Do it as a homework. Okay, next time I'm going to check it. Now, earlier we have discussed about oxy acids and binary acids. So today we are going to cover what is oxy acid and what is binary acid. Okay, so binary acid, we know that binary means 2. Oxy acid means somewhere oxygens are involved. So as name subject, oxygen involvement is there. Okay, binary means 2 molecules containing 2 elements. One element is hydrogen and the other is non-metal elements. So it is a general definition where 2 elements are present together. One element is fixed as a hydrogen and other element is any non-metal. Okay, so any non-metal except oxygen that doesn't contain oxygen. Okay, remember that. So it is not, oxygen is not present, but in case of oxy acid, definitely oxygen is present. So acid containing an oxygen atom in the molecule is oxy acid. Binary acid is where hydrogen is present as a one element and other non-metal is present where oxygen is not there among them. So it is contain at least one oxygen atom in the molecule for oxy acids, and hydrogen are attracted to other non-metal element. Proton in the case of binary acid, and proton that is donated attached to the oxygen atoms are called as proton that is as oxy acids. Okay, so this is all for today's class. Next we are going to do more examples on naming of the binary acids, oxy acids, and whatever nomenclature. I'll give you some worksheet to solve. That's nice. Thank you for being with us. Thank you for, it's really nice having you on this class. And thank you for choosing eTutor.